Hello everyone and welcome into yet another live stream. And today we will be chemistry stuff again. Yes, this should be fine. All right, great. Let's do it. This time actually might do a bit more because we will not only write, we'll probably also work some models, more accurate models of an atom would be neat. Yeah, there's most of it taken up by the cells. Okay, abstraction -1. That's what we are looking for. And atoms. Energy atoms. Yup. This. Cool. Atoms. That's history. We don't really care about that. Laws delete. Okay. Cool. That's what we are. 3 times 10 to 22nd copper atoms. That's a couple. Alright, the language function. The calculator as well as yeah, we are going straight. That's about the chapter. Atomic theory. Let's see. That's history. That's kind of mostly history. That's a bit obvious history. And oh no, mind. Okay, cool. Starting materials, product change, cool, nice, good to know. Yup. Look at something interesting. Like about art and something like that. Because neat. I don't really know what to say here. All these are rather obvious. Hi, the soda. Yeah, you mean 99? Yeah, we are. Yeah. I should probably get the music down a bit. Yeah, so very close. So unbelievably very close. And as you can see, the day for day 99, I chose something extremely exciting. For day 100, we'll be with Elliot. We'll be playing Civilizations because promised them a while back, so that would be more exciting. That would be a longer and more exciting stream. But for now, we have to go through day 99 in order for day 100, which might be okay. Let me actually check my PayPal. I transferred some money to my PayPal in order to have some banking issues. It doesn't matter, it's boring. Anyway, the point is that I transferred some money and I want to see if it's security questions. I don't care about security. Oh, it's here. Yes, money was transferred. You know what that means? I'll be able to pay $100 after this stream. And then, so that's for the 100, the 100. That's sick! I'll try to split this $100. Yeah. Okay. Anyhow, chemistry, right? Yeah, that's what we're doing today. Great. You have to understand that I so far have spent $300. Well, today will be the day when I spent $300 on charity. Something together, 296, I think, and that's more money than I spent on anything else in the past, well, a while. And I don't mean the obvious necessary things. I mean like things for fun, something like that. That's more than I spent on video games my entire life. And that's a fact. That's fun. Oh damn. Anyway, chemistry, right? Yeah, that's CO2 causes, yep. So that's just a lot. It's showing you how electrons, cool. That's electron. Once again, it's a lot of history here. I mean, I get why history would be useful, but it is pointless. I think, Mr. Mist, I think people I do genuinely think that people who write these books, write these things, not the library text, only the most of the normal textbooks for different school, college, it doesn't matter. I feel like for them, this history is interesting because they are experts, and usually experts, when they are talking about something, history about their field is interesting for them. But it's really not interesting for students. Most of these things are sick. They are sick. I mean, this is science by itself is rather sick. Like based on this book, you could build an atomic bomb if you wanted to, theoretically. So yeah, it is sick. The problem is that they add a lot of information which is not necessary. Like discovery of electron. Absolutely no one cares how electron was discovered. Well, experts care, but A charge. Allow them to calculate a charge on a single electron. The information the mass to charge ratio. Mass divided by charge times charge is equal to mass. This is a. What is this? But I mean. But I mean. Oppenheimer style. You better believe it. Oh, that's the demon core thing, right? Yeah, that's. Need to stop them. Okay, glad to know. So. Really distinguished field. Is there anything like actually of value here? Or is it just all history? Because so far they acknowledge that electrons exist and that Robert Millikan calculated the charge on a single electron. On what service I haven't watched yet. Thank you so much. Thank you so much for that. Eternal is dropping, I think, tomorrow, right? That's yeah. I'm uploading vids now every third day, and I'm uploading a new video every third day. I'm streaming every day, and I'm uploading a short every 4 hours. My social life couldn't have been more dead. All right. Sick. Anyway, yeah. What was I doing? Oh yeah, chemistry. I am. Dedication. You can't spell dedication without the dead. Serial investigation began in 1896. Once again, even more chemistry. Oh, Marie Curie. That's with Pierre Frischet Nobel Prize in Physics. That's a fun reference. You know why this is a fun reference? Because Marie Curie was Polish, and absolutely everyone in Poland knows that, because Polish people are incapable of letting go anything that goes remotely close to Poland. So that's a cool little thing, you might not know. Contain radioactivity, yep. Purity polonium, which was named after Poland, once again, fun fact. Oh, did you say she was Mary's native Poland? I'm not saying Polish people have a problem, but oh yeah, pollen after Poland and radium after radioactivity. That's carry the vial of radium. The machine is really glow. Become ill from radiation poisoning. Yeah. He was run over by a strong wagon. Okay. So over here they acknowledge that radiation exists. Charge and mass to charge ratio. Alright. Oh, wat is negative. Excuse me, what is this reference? Much like raisins in plum pudding or chocolate chips in a cookie. Well, I mean, that's not really true, is it? I mean, we're embedded in a uniform sphere that contain both positive charge and most I mean, yeah. But what is... Those model of an arm was incorrect. The fault aimed a stream of alpha particles gold for targets and examine how alpha particles were scattered by the foil. Looks in sheets, minimizing the number of atoms in target. Where correct, positive charge already crushed the uniform distributed mass. Were deflected at large angles from the source. We fired 15-inch shell at a piece of tissue paper and came back and hit you. Okay. So expected and what actually happened. Got it. Which means that's the discovery of nuclei, right? Yeah, nucleus. And as I said, history. And then the kernel model, electrons. Yeah. Electrons are a mess. Yeah, okay, finally, we got somewhere, cool. Yeah, something I knew about, but at the same time I am an idiot, so I probably would have gotten it wrong, so just in case, double checking yourself is always a smart way to do it, especially when you have the source on the one half of the screen. Then that the atom contains very small nucleus composed of charged protons and uncharged neutrons. Okay, let's create a graphic for this. Blender. Don't mind why my icons were so close together, it's just stuff. Anyway, desktop. Projects. Space, life and time. Resources. yes, abstraction -1, and this will be atoms from size. Now doing it to scale might be ever so slightly difficult, mostly because of the fact that diameter of an atom is on the order of 10 to -10 meters, as the diameter of the nucleus is roughly 10 to -15 meters, 100 times smaller. So that means 10 to the -10, that would be 100 picometers. Yup. So 100 picometers. Let's make this a bit bigger, like this big, I suppose. This is actually fun. I'm walking right now on the video where I could use that. That's convenient. Who would have thought that making graphics was actually a smart idea? Cool. So that's the size of the atom. It's insane now, actually, how the difference. -10 to -15, which is femto. Okay, so we need a femto ruler. Femto ruler. Now, what is a femto ruler? Well, so glad no one asked. Femto ruler will be a ruler with size of 1 femtometer as a reference to make sure that our scale is not off. Now we will have to change our view to be a bit smaller, and it's basically a good idea in Blender to actually keep it like this big, and if it's off, that means you have to make something larger, because then it will just break you. Really upsetting news. Okay, cool, it works. Now all we need is start with the femto ruler, femto meter. Now let's turn that into a ruler by adding an array like this, a bit less over here. There we go. Whoa, that's terrifying. Darkness of space. Okay, now we have to apply this thing.
What if it bumped that control by accident? You'd be mincemeat by
Yep.
now. What have I told you?
All right, I guess I wasn't thinking.
You weren't thinking.
And now
You'll work on engines and machinery and not think of your own personal safety? Here, shake hands with danger.
there we go. Now we can add an array which goes up. Like this. And it's good that they are offset because then you can see it a bit more clearly. And now let's do 50. There we go, that's 100 femtometers. Yes, right here. That's neat. That's very neat. Now let's just... Actually, I can copy this to the side, and this, multiply this by 100. And now this is the size of, so this is femtometer 1 to 100, and this is a femtometer, right here is a femtometer from 100 to 10 picometers? 10 to the pico, right? 10 pico. Femto pico, yes, 10 pico. That's great. So we have... This is 100 femtometers. This on the right is 100, so 1, 2, 3, 4, 5, 6, 7, 9, 10. That's a picometer. Now we zoom out. This entire thing is 10 picometers, so means if we copy this over here, we can name that from 10 pico, which will be the smallest bit, up to 10 times 100, which means 1 nanometer, right? 1 nano. It's... Am I really this much of a nerd? Do I remember that? I do remember that. That's sad. That's very sad. Cool. So now we have to just make this bigger 100 times. As you can see, it kind of breaks when we are this big, which means we have to... now one of these is... wait, one of these, right now, one of these bugs 100... no, 10 picometers. How many what now is this? This is 10 to the negative 10, which means it's... 100 picometers. Yes, 1/10 of a nanometer. Which means when we have this ball should be the size of 10 things over here. 1, 2, 3, 4, 5, 7, 8, 9 and a half. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and a bit to count for that. So this is the size of an atom. That's an atom. And now if this is an atom, then if we zoom in, right, past the glorious rulers, there we go. This right here would be the size of a nucleus. It's tiny, absolutely tiny. It's absolutely tiny. I genuinely for a second thought, oh yeah, this is the smallest size, was then, oh yeah, there's this size too. It's absolutely tiny. Yeah. Size of blueberry, and atom would be size of almost. Yeah, well, I think we've got the size difference. Atomic mass units. Fundamental unit of charge. The mu was origin based on the hydrogen, less on the but then it was oxygen since Bendai was defined with. Yeah, as a top of carbon, atoms which are assigned mass exactly 12 mu. Cool. Oh, I have -1 view again. What the f- Why? Why again? What happened? Why is this thing? Why is it an actual thing that happens? Give me a second. Okay. I'm back. Who's unviewing me? Why would anyone? Okay. Now, it's time to do a couple renders actually. A couple. I feel like this one should be a mission because yeah, I obviously want to create some graphics for this. Oh, as cinematic as that looks, I feel like this should also be a mission. And this should also be a mission. Except right now, yeah, right now it is. Great. I know a lot of grain on the screen, I get it, but there we go. Now what we should do is, oh my goodness, there's actually really a lot of grain on the screen. Start with adding depth to a camera, like this. That's what I needed. Transparent. Transparent. I really want to showcase the actual thing. Yes. Oh my goodness, massive. Okay. And also possibly prepare an animation for later video. I'm just, you know, just saying. Let's remove this. That's pointless and add volume.
There's a guy named Jones, lab man. He makes prints of films. He handled this print. Then there's Smith. He's a film distributor. He sent the print to the station. And Brown. He's film director at the station. I know. You're trying to make me the ball guy. And Harris, projectionist at the station. I only had that print long enough to thread her up.
Yeah, this is what animating film actually looks like most part. Apart from the you know the good animations which actually take the animating process to it. Over here.
We don't know. All we got are suspects. My job, find out who.
Right, not this, only from the other side. This. There we go. And then we'll just render it out there. 100, 200, 300 to showcase the sizes. So tiny. So absolutely tiny.
My job, find out who.
There we go. So tiny. That's what she said, but you know.
Somebody's guilty.
Render an image.
What if they stick to their stories? We're stuck with a perfect crime. It happens. More than you think.
And that's a 10 picometers, right? No, 10. Yeah, 10 picometers. That's a femto roulette, so this 10 picometers. So this would be atom size nucleus 0. Yep. Then 100. And that's because of the nucleus, except this 1 square over here is equal to 100 femtometers. Yes, 100 femtometers. This, except with this tiny ruler it has. Save. That's, there we go, and 300. And that's the nucleus. Well, it's small. It is small. Okay, cool. I think it's a very small nucleus.
Look, I've got an idea.
So you have the atom contains atom is comprised of the nucleus and a much larger volume of space containing electrons. Negatively charged would be the redundant information. So now what we can do is now we can do 3, 4. Fourth it will be nucleus and electrons, because both of these are rather complex, starting with size of the nucleus, not area, only times in Roman. There we go. Size of the nucleus. the nucleus of an atom is several orders of magnitude smaller than Is there a name for this, space containing charged electrons? Equation, yeah, this one. 10 to the negative 10 meters, and the nucleus here around multiple events to bit of a weird thing to paste over there. 10 to the negative 15 meters. Here we can see, actually here should be down right, yeah. Here we can see 4 different images, each having with in this order the atom next to a nano ruler. Each segment has 10 picometers, if I'm not mistaken. Yeah, 10 picometers. Inside of pico just means which order of magnitude, you know, what around what scale is it, right? Pico inside of an atom. Each segment has 100. Because this ruler has 10 this ruler has a nanometer. The one inside has 100 femtometers. Femtometers. The femtoruler inside of an atom. Each segment has 1 meter. Femto and the pico ruler has 100 femtometers and 1 femtometer, and the femtoruler next to the nucleus of an atom. Okay, and now all we have to do is just add those images there. What happened? Okay, we're back. What I need right now is File Explorer Atoms, and can I just drop all of them here?
Flying V payroll's been robbed. V-Bell has been kidnapped. Tell the boys to ride. Where art thou, buddy? Where's the Flying V payroll?
Text too. Size limitation. Size. That's inches. Why is it in inches? Okay, so we have to do this. Okay, 50. 50. Oh, every single time it did change.
Somebody held up the jitney. Probably the Higgs gang.
50.
Bring your horse. They're headed for Pine Creek.
Cool.
Guess they're going through the gap. Hurry up and I'll meet you flanks.
325, 183. 183. I don't know why are they scaling differently. That's kind of cool. This and this. And all of them just moved, straight up moved. Which will need some space for this. Thank you. view over here. Google Docs is not that great of images. Okay, I'm pretty certain the other two are under this page. How am I even going to get them out of there? Okay, branches of the footer, that's a... How am I going to get those from... Okay.
Where's the Plan B payroll?
That's how. Stuff. Get them out there. No chance. And over here, by the way, and now you go up. Actually, delete you. Fine, we'll set up again from the beginning. There we go. Now, so that's the 0. Now it's time for the 1 over here. Size. Over here, size annotation 50. Type of text. Like this. Great. Now this. Yeah, it might be a bit too close. I can see it now, but it's so ugly. Why is it so ugly? Okay, this looks better. Cool. That's the step by step, and yeah. Yeah, these are tiny. These are tiny. That's the point. That's the point, and that's it. That's all I'm saying about this point. What's happening to... Okay. Okay, get it. That space is important. We'll keep it. Cool. So now, what's next? Well. Extremely small. For example, carbon atoms. A carbon atom weighs less than 2 times 10 to 20 negative 30 grams, which is a bit small. It's the 3.25 AMU. The atomic mass unit equal to equation. So we know that's track 112 of carbon 12, right? Carbon 12 to 112 of the mass of the carbon 12 atom. Equal to around equal to around 1.6605 minus 10 to the power of negative 24 grams. Cool. When it comes to the charge, the fundamental E is equal to 1.602 times 10 to the power negative 19. Cool. I feel like I should add this to electrons, right? Or maybe this entire paragraph actually. Why is it going so high up? The entire paragraph should probably be next to atoms. Over here. There we go. Cost of electrons. That's a good table. Then, nope, not both. Over here we will soon add some more text about those electrons. A single proton plus a charge equal to this. Not this on the equation. Proton's charge equal to 1,602 times 10 to the negative 19th power. A positive charge and a mass equal to, I'll do it in grams because I'm a monster. 260 neutron. Just copy this and actually change it a bit. Its charge has no charge. No charge. No charge equal to no charge, and the mass equal to 167,493. Units are dangerous if you just, go around them like that, without using one specific on the AMU and crazy stuff. Electrons.
To enjoy the clear, cold days of winter, when the earth is buried under its glistening blanket of snow.
Electron has a negative charge equal to 1 electron of charge. Would you believe that? I just realized I've got. Actually, look at that. Proton and electron have a negative charge. What a coincidence, am I right? What a coincidence. I've got one. See over here. There we go. NOP grams. It's actually very dumb way to do it. There we go. Grams. This 1 2 3 zeros, not 1. And 0 over here too. Reason we could just add 25, 6, 7, 7. There we go. Much better. Now, number of protons in the nucleus of an atom is its atomic number. Any atom that contains 6 protons is the element carbon and has atomic number 6. It makes sense that the number of protons is more important because they have the charge, right? Yeah, I'm writing this exactly. Of an atom is called an atomic number. Damn it, it's not Control V, Control B, and it dictates the identity of the atom. For example, any atom that contains. I feel bad. I feel like I'm ripping them off because there are two options. Either I just copy the carbon example too, or I go with oxygen, which seems like a very lazy way to go around this. Oh yeah, Google has this really cool to table. Yeah, this one. It's not. It's like I could just rob them of the oxygen, but. It feels like going around in a very lazy way, but it's a good example. 8 protons is the element oxygen and has the atomic number 8. That's also a very important thing to add, regardless of how many neutrons. It's very well written. A neutral atom must contain the same number of positive and negative charges. So but also indicates number of electrons of an atom. Wait a second. It dictates number of electrons in an atom if it's a neutral atom. Total number of protons and neutrons in an atom is called its mass number. But I'm pretty certain atoms don't have to be neutral. Okay, I may be wrong. Has an electric charge? Yes, they don't have to be neutral. I feel powerful right now that because I do believe it's the first time in history that a YouTuber used the word iron and was correct. For the first time in history, a YouTuber used the word iron and it wasn't clickbait. Would you look at that? Okay, YouTuber may know that word, Naired after all. Maybe a streamer. Oh, there we go, that's much better. Okay, cool. So if the atom is neutral, but that's kind of obvious. If the atom is neutral, then it has the same amount of, because then you can just check the charge. But okay, I know it might be obvious, but I'm still should add it. If the atom is neutral, will have the same number of protons and neutrons. That's something I remember my chemistry teacher. I was always mad at my chemistry teacher because she didn't explain that well. She was very harsh in general, and so because of that I was genuinely, well, I mostly didn't care, but she wasn't approachable, and because of that I never actually asked her about it. And I always wondered, well, not always, but for a really long time, for years, I wondered why, it was my college chemistry teacher, I wondered why, how some atoms can be unbalanced and stuff like that, how ions work in general. Discuss charge will be acquired charge beginning losing electrons. Yep. While more electrons negative charge, onion. Most cations. Oh, come on. That's actually awful. Yeah, I'm not here to... By the way, this paper isn't here to teach standards or anything like it. If you go up, you'll notice that in quantum physics, one thing that's very interesting about quantum physics here is that there's a lot of things like these, right? But you may notice that there is nothing here about actual experiments. And that's for a reason. This is supposed to be a guide on how to build a human if you only know quarks. And so, because of that, it requires a lot of knowledge, and in the end it will have around 1,000, maybe 2,000 pages. But if I were to include all the reasons why what I'm saying is true, then it would have 20,000 pages. So instead what I do is I go down here and add this, if anyone is curious. This has everything from the book that I'm reading right now on stream, which is fortunately open source, that's why I'm reading on stream, to a quantum physics lecture, which I used in my video about quantum physics. Yeah, it's a lot of stuff is there. Alright. Now, I am glad that I'm doing on stream though, because one of my biggest fears is that one day someone will just tell me that I didn't write this, or I, something like that, just copy it from somewhere. No, I did write this, surprisingly. I know. Deuterium tritium, very famous for its use in making energy in a very clickbait way. That's why not. Because people can tell you, hydrogen, that thing that's in the water. Well, you can use hydrogen and helium to make a lot of energy, and they didn't, they just forgot to mention that tritium is actually extremely rare. extremely rare. Yeah, so it makes sense. Top is protons, neutrons. Well, top, yeah, right. It's a mass number. I think I said it wrong right now. No, it's protons, neutrons. I'm an idiot, yeah. Insufficient, yeah. Oh, wow, that's... carrying on. Vapor is sampled, ions, accelerated, electron beam source, I'm sorry, but all of these names. Okay, cool. Glossary, yeah. Chemical symbol, Dalton, units, fundamental charge, ion, mass number. Yes. There's nothing here. Oh wait, because that's okay. Patterns in the periodic table. I suppose I should right now add the periodic table to the paper, which is one thing I was really scared of. Because periodic table will take up a lot of space, and there isn't really much to say about it in that space. Which means it will take up like an entire page for me to just say kind of what it is and why it's useful.
Hey, Johnny, well, I guess it's time to put our songs away for another day and to say so long to all you nice people out there.
Rationale for the format of periodic table is explained later, yeah. One, two, or three is the symbol, but if you need 3 letters, that means you're insane.
We all enjoy being together, but is anyone left out? Think so. Well, that's our guest list.
In the neutral atom, number of electrons equals number of protons, literally what I said. Great.
Dear Alice, would you like to come to a party at my
So I guess over here we should then add after electrons, which we still haven't filled, by the way, and protons and neutrons, which we also still haven't filled. We should add the properties of different atoms. In which case we'll have to. So first we'll have metals, and no, the second will not be non-metals. Second will be a placeholder now, because actually have metals and it will be metals, non-metals, semi-metals. It's just one way to group them. That's the point.
next business refreshment? We have to feed the men and the girls too, especially
So starting with metals.
the show.
We have various metals. And there's the metals and non-metals. And the diagonal line exhibit properties intermediate between metals and non-metals, they're called semi-metals. but we are looking for the properties of metals, right? That's the thing. It's one of the most fundamental chemistry. Metals are good conductors. Electricity and heat.
Alright, now next is
Ductile?
energy.
Is that...
We want to show Steve a good time, but
Does that mean what I think
we
it
don't know
means?
too much about what he likes. The best thing I know for breaking the ice and getting people
Because,
excited
I mean,
is the mustard man.
It's a big night.
it was not exactly what I meant. I mean, I knew that was about this, but I thought it meant a bit different toughness. Good knowing, so we knew every day it's my shoes. Ductile. Shouldn't, because malleable. Most have shiny appearance. I am not adding that. Lustrous though. I am adding that. Generally known elements are metals. Only mercury is a liquid. Different temperatures are solids. Don't care about that. Now non-metals. Poor conductors. Brittle. Brittle.
Hey, Rick. What do you got? Wasn't that the Johnson rag playing cha-cha-cha?
You sound like yes, it was. It sure was.
But I never heard it played that way before.
Well, a good tune can be done anyway. Now wait a minute. Hold it, lad. Wait a minute.
Wait just a minute.
Semi-metals.
Like another tip?
Johnson, no.
Exhibit properties. Intermediate between metals and non-metals. Yeah, I am still alive. I mean live. Yeah, that's... Yep. No, chemistry stuff. Don't mind the irons. It wasn't clickbait, trust me. I mean... I feel like... periodic table will require an entire chapter of its own. This is a cheat sheet, right? Yep. So, before matter... On the beginning, obviously, this periodic table we're talking about, so... the periodic table. And this will be a massive one, too. Wait, is it really 2? Huh. Oh, that was my lamp. These images don't work. What is this doing here? This should not be here. Okay, great. Yeah, now properties of different atoms. This is inside atoms, right? Yes, good. When it comes to the periodic table, obviously, I'll try to divide it. Well, first of all, we will need some sort of graphic of the periodic table, which I will not copy off the internet. I will actually make soon. I should get a video about periodic table. There's so many video ideas just from this paper. That's profit. Well, first we'll do group division, in which we'll discuss every single group. So we'll have first group first, that's kind of what we're going for here. And now this will be the alkali metals. Lithium, sodium, potassium, indium, calcium, francium. Oh no, is it called because of France? Don't tell me. name, but why is it called that? What this is francium? Looks like France. Why was it called? Please then, why is it called francium? History. Why is it application history? Yeah, that's, well, I mean, it is kind of full of science, so it's not hard to find. No! No! Okay, is it before or after polonium? No, please tell me polonium was first. Polonium. Wait, first group, right? Yeah! Okay. Oh yeah. Damn it! Oh, no, not front. Okay. Okay. Anyway. Oh yeah, we're doing science, right? Yeah. So, okay, I'll do a stream about top 100 reasons why France shouldn't exist later on. For now. Okay. Let me first open up my, because you know, you may not know it, but I have kind of a thing here, the meme channel. And listen, I'm not saying that memes that I'm sending here are biased towards something, just... I'm not saying that. Okay. Cool. So, minerals. Yes, that's what we're doing here today, right. And the alkaline. Now I should probably describe them. It is actually very fun to see. On the beginning, chemistry is very, well, it sucks. It sucks. I have, for the, well, we are on the second chapter because it's the second stream of that. And it just sucks, but later on, alright, you have to give it a second. It's the relatively boring stuff. Give it a second. Should be any second now. Nope, still. No, this is a race of the fusion. What's gonna... Okay, my hopes are going down, but somewhere over here. The train track terms from oh wait! I think I found it. Yes. Over here, surprisingly early actually, it's a quarter of a book. This is actually borderline quantum physics. This is borderline quantum physics. And I dig it. You have
Where are we going?
it's sick. I mean, whenever I studied chemistry, alright, normally, we never got to quantum physics. What a ripoff. What's the point? What's the point if you never get to I'm just saying. What's the point in studying this SMH? Alright, group first, right? First. One example was stable salt, but we're looking for some properties. Okay, so one thing, and there's actually, I was impressed by that. There's a lot of I should calm down first. Okay, there is a lot, and I do mean a lot, about wavelengths of different things, and surprisingly a lot. The thing is, it's kind of hard to explain why that has to do a lot of quantum physics without actually understanding chemistry. So I won't even attempt. But it is, as I said, it's borderline quantum physics because it's not treating particles as no atoms, polarize and realize. No. The thing is, okay, there was this one specific chapter. That's how I found this book, because I was just recently for a video, and there was one specific chapter dedicated to wave-like property. I'm pretty certain wave-like properties of matter. Let me check. Maybe I have it open somewhere. Oh, would you look at that? Would you look at that? Wave character of matter. That is quantum physics. That's quantum physics. And that's this book, chapter 7.4. This is actually advanced quantum physics too. That is insanely cool. The only question I have is, why did I never get there? Dumb classes. but that is insanely sick. Over here you have a way to calculate. They calculate the wavelength of a baseball. Wavelength of a base. Obviously, this is a bit. There's something fishy about this. I wanted to use it in my video to calculate the speed of a. Yeah, but there's something fishy about this, because I wanted to use it in my video where I calculated the speed of a particle based on temperature. The only problem is we have velocity of a particle. If something is not moving, then in theory this would be infinity. That's what's fishy about this. Particles such as electron could be described by a wave whose wavelength is given by. This is. Okay, please tell me, internet. Please tell me you have my back. Quantum mechanics. Yes, I know this name. So that is sick, and we will get there. If I'm doing one chapter per live stream, then we should get there in 5 more live streams. Obviously, won't be streaming this every day, because I don't want to kill my channel yet. But I will stream it more often, that's certain. And if I'll have some more free time, then I'll first start the day by streaming Charity Checkup, and then I'll stream this apart from Charity Checkup, just normal space, life, and time writing. Oh yeah. Table salt, lithium compounds are used in grease and batteries, and as drugs to treat patients who exhibit manic depressive bipolar behavior. You mean I can eat salt and not be sad? Lithium, rhodium, and calcium are relatively rare in nature, and francium is unstable and highly radioactive. Okay, you better believe I will use every chance I have. You better believe I will take every chance I have to absolutely. Later on I'll be playing Civilizations. I really hope that I'll be able to destroy France. Either destroy France or be France and destroy myself. Now sodium and potassium are 7 to 8 more abundant in the crust respectively, so there is absolutely nothing here about the properties of alkali metals, which is what I needed. Is it just a name group, or does it actually have something to do? Soft, highly reflective. Readily loose. Okay, now we're getting somewhere. Yeah, that's better. Well, I don't want to say with shiny. It's kind of a weird description. Yeah, I'm a chemist. It's shiny. Soft. Okay, let's soft. Damn, I love this music. It's copyright free. Shiny. Highly reactive. At standard temperature and pressure. That's a bit of a downside to this definition. Well, readily lose one of their outermost electron. That is a synonym, right? To reactive, right? Yeah, that would be a synonym, but this is more precise. It's kind of screwed myself over with this R over here. Well, R ready to lose their outermost electron. I don't like that. Definition. Fine. They must be stored oil. That's, yep. Sodium is a great example of that. Oh, potassium actually too. These are a bit more rare, but potassium, sodium. And actually, on salts. Yep. Okay, sodium is more advanced, followed by potassium, lithium. I may be wrong, but that's just... Oh, never mind, sodium is the most fine. Potassium, lithium, that's not the other ones I was expecting. Wait, what? Relativistic effects. You have quite an eye. What? Elemental properties and structure, especially for heavy elements on the periodic table. Well, that's quite a read. Are important for heavy elements with high atomic numbers. Okay, I don't want to get into that yet. I suppose I still haven't written, and yeah, I still haven't written anything about relativistic anything actually. It's surprisingly intuitive. Actually. Relativity. It is surprisingly intuitive, but I don't know to what abstraction I should add it. Abstraction -1? Maybe. It's not really quantum physics. Yeah. Actually, damn it. I should add something about relativity. It's important. It's very important. The problem is that for relativity, you basically need high masses, high speeds, high stuff in general in order to actually showcase it. You need something in comparison to the speed of light for it to show the true effects. And gravity is the same. Now, let's see. Alkaline earth metals. Let's go back to the boring stuff, alright? This stream was getting too interesting and I can't have that. No gases will be the most obvious ones. Britannica! Oh yes. Properties what you're looking for. Easily lose electrons to become positive ions. That's the alkali. We're looking at alkaline. No wait. There's this. But that's the same thing. Oh, but these lose plural. Okay, yeah. Can see it. Adef ionic. As I said, this is the first time during the boring stuff. You have to. I mean, I would love to stream more of this sort of thing. The only problem is that I really feel guilty when people join. I genuinely feel guilty because I know I could be streaming Doom right now. I could be streaming Doom Eternal on the Ultra Nightmare difficulty. I mean, that if that isn't clickbait, then I know this. But yeah, I should probably do more of this. I should do more of this. My channel is an edutainment channel, for goodness sake. What am I doing gaming? Well, I'm collecting money for charity at https://mediaw/charity/within.make charity DBS Alliance and get started off buy for yourself in case you'd like to. Once again, that's https://mediaw/charity/within.make some money to charity DBS Alliance and get a slice of pie for yourself. Oh, there's actually wait. Okay, there's. Okay, I could. Okay, well, I mean. Okay, in theory. I'm not saying I will. I'm saying I do have a printer, an old printer, and I'm also saying that in theory, if I were to read, well, okay. There surely is some kind of standard for USB for keyboards and mouse. Well, yeah, there definitely is, because there is a project for Arduino Nano which simulates that, which means if I get that, I could write something in Python, play Doom IRL. That is okay. Well, I mean, would be way more interesting. I mean, well, I mean, if I can get. I can also build a shotgun, that would be easier than doing this entire thing. That's true. I also have a hammer. Why not a shotgun? I should do Make It Builds a Weapon episode 2, but this time carry on. I should, but actually I should do Make It Builds a Weapon episode 2. I haven't broken any laws recently, and as a YouTuber I can't have that. What are we doing here being moral, am I right? It's like, views are not going to up themselves. Hello everyone and welcome into yet another video, and today we will build a nuclear reactor. Special for 1000 views. It's very tempting for me. You have no idea how tempting it is for me to, once I get monetized, as my first video, do a special and demonetize my channel by, I don't know, showing you how to make poison or something like that. Railgun! I genuinely want to build a railgun, and I will build a railgun. Well, technically a coil gun. What's the difference anyway? Coil gun. Did you know that there's an entire equation for calculating the energy to projectile speed, and that's it. That's the equation. Don't ask me how I know it. There's ever so slight possibility that I already have plans for building a coil gun, but there's an equation for calculating the exit velocity of a projectile out of a coil gun based, well, you can see based on what, but, and based on that we okay, I can use a single battery to make bullet go over 100 meters per second. That's the real science here. The only problem is that there are some weird things like this and finding disability and stuff like that for humanity. There is someone out there who probably wrote a paper about this and later on how to explain to people why they wrote a paper about the equation on coil gun. Properties. How close are we to the end of the chapter? We are on page 94. Okay, that's terrifying. No, it's 3-2. It's a really good chapter. We are 60 away. We are actually very close. 400 of course, obviously. That's what I have written on my YouTube about. Not you. Okay, let's do like a true Chad. Oh, what a cool live stream! Oh boy. Hunting. Yeah, that's what it is. Yeah, but I feel like railgun would be really expensive. I mean railgun. I feel like railgun would be. Well, I mean. I feel like, yeah, it would be a bit expensive. That's my only issue with this. Otherwise, I'll be more than happy to build some giant transistors to, you know. I don't even know what should I do with a railgun. It's a railgun. Mach 5.9. Okay, here's the thing. This is very fun. Rocket launch into orbit. This all looks very fun. Not gonna lie, all of this actually looks extremely fun the more far I go in. But what's the People's Republic of China? Why is the people? What? That's just one of the. Oh, okay, cool. That's the whole point of it. Well, yeah, I mean, why walk on quantum physics if you're not going to build a nuclear bomb? That's what I'm saying. Oppenheimer style. I will build the railgun. That's one thing on my bucket list. So. 2 valence electrons, that's obviously because of the group. Low ionization energy. That's, yep. Highly reactive, well, might as well add that.
You see what low grade you made on your weekly mathematics test? More than half of you failed. Most of those who
Highly reactive.
the poorest class I've had in a long, long time.
There's actually quite a bit to still do in this paper, but we are getting close to at least the first version being finished. Because this is already a lot about chemistry. It's not a lot in comparison to the entire field of chemistry, but it's a lot to nothing in comparison to nothing, so... Also quantum physics is quite a bit. I have to finish math, Slavic calculus, that's my kind of main thing. Okay, these are... Most advanced science equipment is still essentially just It is. But I mean, it's, you know, it's slamming them together in a very sophisticated way. The most advanced thing in the world, you know, built only to. Well, in theory, you could argue that the most sophisticated and advanced piece of equipment out there is just a giant gun. Slash that, 2 giant guns actually, because you could argue. I'm just saying. We used all of humanity's greatest minds to build 2 giant guns. Science! Purpose. Answer. Yeah, let's be real, it's a gun. I love science, let's build more guns. But this is insane though. I mean... that's a gun. It's also really fun to see what kind of research is done with Great Hadron Collider. It's insane. It makes what I'm doing here look like counting the fingers. Science gun sounds like hell of a thing. Oh yeah, we're doing this, right? Yeah. Wait, good conducts of electricity. Oh yeah, metal something. I was thinking about something else. Active good conductors. No, I should do it with a single source, like properly, not like this. Have acid. I do have acid, so what would be a good source for this? There's only one thing that upsets me on these streams, and that's the fact that I cannot play the Stupendium. That's the only thing that upsets me. If I could play Stupendium, my playlist of 20 couple songs of Stupendium, which I most of them have memorized by now, that's all I need for happiness. I guess we could do Wikipedia. Characteristics, that's like a much more personal properties, right? Check them out. Oh, you don't know. I'm a bit of a fan. Stupendium is... I'm a bit of a fan, let's just say. Okay, I'll fill in this later on because this requires a good source, which I do not have at the moment. So instead we will need 3, 4, 5, 6, 7, 8, 9, 10. We need to get to 17. The halogens. The noble gases. Noble gases will be the easiest one to fill in. For now, let's just add blue in here so that people won't think I'm insane. People, as if anyone's going to read this. There's only one thing that's I think so far is worth reading, and that's the quantum physics. Well, I've shown this is amazing. None instead. Yeah, but it's not a number. Get it? Because it's actually not a number. So none. I'm sorry, I don't understand. I'm a C programmer. There's no such thing as not a number. I should really get some friends. C programmer. Am I right? That's crazy. Okay, molecular weights. That sounds like something that. Oh, these are just moles. Right? Average atomic mass, mass of electron, proton, the mass of any given atom is not simply the sum of masses. Obviously, it's not. Neutrons, for example, the ratio mass of hydrogen is actually. Difference amount small is extremely important because it is the source of huge amounts of energy released in reactions. Yes, cool. So should add it probably somewhere. This isn't actually chemistry, it's chemistry and physics. Normal physics, conventional. The negative one obstruction. So probably if I were to add relativity anywhere, it would be probably over here. Now, average atomic mass, so probably should add atoms. Mass of any given atom. Mass, yep. Because are too small to measure, there's no convenient way to accurately measure absolute atomic masses. Scientists can measure relative atomic masses accurately, however, using an instrument. Mass spectrometer. As I said, there won't be anything about experiments, so it's not just simply the mass of all. And neutrons, and now the example would be in order. For example, the ratio. I won't even try to come up with a different example. I know I said I really don't like copying stuff, and I still don't, but well, making up examples is a bad idea. So still will use this one. Of hydrogen and deuterium is actually equal to insert equation. Okay, cool. What's next? So, value ratio of the mass. Okay, is it only me or is this like completely bizarre? That the mass divided by... This equation is... I already mentioned it, but it's... It feels off. It's... I mean... I get what they're trying to say, but this equation is just comical. Mixture of ice dope. Okay. Summary. Average number of protons as well as number of protons neutrons. Density charge each atom. Yep. Okay. Molar mass.
Now, all over the country this month, thousands of people are going to summer camp.
Avogadro's number. Oh, you should add as a constant. That's important. At the beginning of every single abstraction, I add constants. So over here we have units in the cheat sheet. We should also have constants. And over here, for the first time, we have Avogadro's number, which feels like an appropriate constant to start with. It's pretty, important. Which is... Yep. Anything you like apple stars in the sky burritos. That's every chemistry teacher ever. Units, people, units. You have to remember about units.
Where they awake every morning and go to sleep every night, trained to the jugo.
Number just
So the Allied Brigadiers thought it would be a
chemist doesn't. It's not. It's very much not.
Okay, boys, better roll.
Avogadro's number is the to do with more. As I said, most are so unbelievably weird. I'm pretty certain Steve Mold made a great video about that, right? Steve Moles. I misspelled that. Yeah, actually good explanation of moles, and it is actually a good explanation of moles. The point is that, as it said in the previous chapter, that this would be kind of explanation. I'm not a chemist, it's a bad idea to actually for me to explain anything. The thing is, it's yep, the current value of the measuring distance between atoms of silicon. Yeah, so basically we combine the measured mass of the sphere into the Avogadro's number. To revise definitions of both. Wait, isn't kilogram actually well defined? It's defined based on the Planck constant. And the definition of a second in a meter, so I'm pretty certain it is well defined. Chemical entity, which can be an atom, molecule, formula, like, yep. 1 mole of anything is just Avogadro number of something. It's just great. These, as I said, these definitions are so extremely confusing. Yeah, it was, but you know, this is a better definition from the physical sense, because this definition will never change, and you can use it mathematically if you want, because it's defined based on 3 constants, based on speed of light, based on hyperfine transition frequency of the casing 133 atom, and based on the Planck's constant, which means these are 3 very solid constants. First one, which is as solid as it gets, second one, which is very solid, and the third one, which, well, you can just measure if you want. That's why this definition is more complex, but it's the most precise. As a definition, substance contains as many elementary entities as there are atoms in 0.012 kilogram of carbon 12. Yeah, so that's what the Avogadro's number is. Avogadro's number is basically a number of atoms in 0.012 kilograms of carbon 12. That's Avogadro's number. I should probably expand it over here. So like this. Avogadro's number is just equal to the number of atoms in 0. Always afraid this because I'm an animal. 0.012 kilogram of carbon 12. Actually, I don't have to use 12 here, but yeah, I should actually, because there's no greater. There we go. That's Avogadro's number. It's also inverse mole. Actually, okay, this example is actually so sick. Wish I used this actually. Atoms? Kind of, maybe. In order to find out how many moles are in X what should I use as a nickel, as a placeholder name? X. It was under matter. I have it here. Wow, the convenient thing, I have it. Element. Yep. X element. You can use the following equation. Considering that Avogadro's number is equal to, and over here we should add the Avogadro's number, the full Avogadro's number, the shortened version. I press Ctrl-Shift-C because I'm used to the terminal, where you can recopy. Ctrl-C like that. No, that cells went too far. Should we get better way? Well, I suppose there's this always, but not when you're using the double screen thing. I lost the thing I was writing. There it is. Is equal to this times, no, this mole to the negative first, because this time we need the unit, which means that then we can use fraction x atoms of the unit, atoms mole to the negative first. Wait, is it? Yeah. And that's equal to. And that's equal to y mole. Yes, that's the equation for finding it. That's Avogadro's number. And there we go. I also should take this and add to it. Format. Let's together. Okay, format. Keep with text. There we go. So works. Now.
Not a chance, fella. Not a chance.
Yep, no worries. Go for it. I'll just stay here, do molar stuff. Molar volume depends on the density of the substance, and like density, it varies with temperature. Oh, expansion. So pressure, yeah, so moles just complicate everything here. volume off. Yep. And here are the exercises, that's it. Yup, so okay, I should add the molar volume then. Molar volume. I would really love to watch this video right now to actually get the feel for what I'm doing. But that's, you know, freebooting. We are not freebooters. X atoms of an element. X atoms of an element. Here's a following equation. In order to find out the molar mass of a chemical compound, you can use the following equation. There we go. Let's copy this. There's a M is equal to molar mass. Cool, now the only thing left to do is figure out what the fuck is molar mass actually. Ratio between the mass and the amount of substance. So it's molar mass is just the grams per atoms. Grams per atoms. Or kilograms per atom, doesn't matter. Molar mass is an average of many instances of the compound.
The mysterious, the unexplainable. That is why you are here. And now, for the first time, we are bringing to you the full story of what happened.
Yeah, so it's just the...
That fateful day.
Oh, so it's the average mass
The places,
of...
my friend, we cannot keep this a secret any longer.
Ah, that makes so much sense.
Shocking facts about grave
It gives you the average mass per instance of the compound. Considering that
shocking facts about grave robbers from outer space.
inside a compound you can find many isotopes. It gives you mass. Yeah, okay, this makes sense now. So that's what molar things are. Now we can go on to molar volume. So molar volume will be the volume for every single... Okay, it makes so much more sense. It feels so good to actually understand. Volume equation, which means volume molar. And that's the molar mass, and that's the... Isn't it P, is it? Doesn't look like a P.
You're in charge now, Lieutenant. Yeah, yes I am. No, yes, sir. Back up the car, gather radio. Tell the coroner he's got to make another trip out here.
Is this a wiki thing? Well, this Wikipedia thing. Because I guess it might not be because it's Wikipedia. Always, there we go. This always tells you row. I knew it wasn't a P.
The shocking fact about
That's a
grave
cool tip for
from
you.
outer space.
So now we have the VM, which is the molar volume. Then we have M, which is the molar mass. And then we have the P, which is what's the weird one here, right? Mass density.
What's left of the horseless carriage? The airplane, the telephone, the electric light, vitamins.
It gives you the
radio,
average
and even
volume
television. And now
per
some of
instance
us
of combat.
laugh at outer space.
Okay, cool. Great, sick. There we go. Another successful addition to the Space Life and Time paper.
The mysterious, the
Oh,
unexplainable.
Shadow Creep. Cloud, no one cares about you.
And now for the
It's
first
getting
time,
pretty massive.
we are bringing to you
Download as PDF using new sources.
fateful day.
Yeah, we did check a couple of things on Wikipedia, but
The places,
it wasn't really
my friend, we cannot keep
much
the
of a source.
secret any longer. Can your heart stand?
Alright, I suppose I should just wait for Tirta. I don't wanna end the stream once it's gone. So... I figure that this is the longest paper I've ever written, which doesn't actually say much. It just says that I mostly write short papers, never finished them. Well, I did finish both Fender, and well, Hyper Operational was a mess, unfortunately. This is actually not really dense, I just realized. Well, this is relatively more dense. Most of it is very floaty, so 30 pages over here, nothing is like 10 on normal paper. Also the biology restarted it because of the model that I made. But this is fun. Really fun. Alright, time to open this. And time to do the thing that I do. Oh, it is actually 0.5.0 based on our original rules. That's fun.
You're in charge now, Lieutenant. Yeah, yes I am. No,
I still will have to change the rules, but that's good enough now. Well, while we're waiting for Terta,
make another trip out here.
I actually know what to do. Two hours? We just spent 2 hours on the research. Nerd. I remember good enough. That's the Amogus chest, the only real chest there is.
The world is watching us this moment. We once laughed at the horseless carriage, the airplane,
Altus Castle.
the electric light, vitamins, radio, and even television. And now some of us laugh at outer space.
This is blocked. Also blocked my own bishop. Like a smart person.
Just what do you expect after 25 years? Come on in, son, and make yourself at home.
Let's see. Oh, they didn't go for that. That's interesting. Actually, I have no idea what they've done. I've done nothing. This is a dumb idea. But it's an idea. It's about as good as it gets. This? No, we didn't. This works. I'm forcing it right now. Never mind! I still very much lost this, and that's it. What's the take? Once again, why am I playing like an idiot? This is actually really good. I can just take this. Ah! Ah! It's even worse. Okay, let's just design. Tefta, where you at? I don't want to end the stream. Can someone back? It's awful. Who do such thing? Well, a streamer, no one.
Just what do you expect after 25 years? Come on in, son, and make yourself at home.
110th page. To be fair, this is a bit more light read in comparison to Grey's Anatomy. Went AFK at the worst time possible. End the stream now. Did I mention how Tefta is responsible for this fucking gif of me?
Hi there. What a wonderful time for you to drop by. You know, they're just setting up to shoot a star.
And it's an emote right now. This is...
Honestly, we're all just bursting with excitement about this brilliant new performer. We think this will not only win
To be
every
fair, it's a
award
sick
but
emote.
it's just going to win the hearts of people all over the country. Come on. I want you to meet a great new star.
These songs are copyright free. Did I mention that? That's insane. I've been using them for, well, a long time. What do now? Did I mention how you can go to https://makeitwtf/charity/ and you manage charity, DBS Alliance, and get a slice of pie for yourself? Did I mention that? I don't know if I mentioned that. I just feel like I should mention that. Now that we're waiting to type that, so I might as well mention that. You know, link in the description, https://makeitwtf/charity/. You can go donate to charity, DBS Alliance, and get a slice of pie for yourself. Or you can go straight out to GoFundMe if you want. No, https://www.gofundme.com/f/e-slice-of-pie. Yeah, it's a mouthful. That's why I prefer https://makeitwtf/charity/. Either one works. If you go to https://makeitwtf/charity/, you can then go to the slice of pie and then donate. So it doesn't really matter. So yeah, https://makeitwtf/charity/ if you want to donate charity, DBS Science, and get a slice of pie for yourself. Just saying. in case you're wondering, I will donate today $100 to that charity. So I'm just saying. So yeah, like https://make.me/short/. That's quite https lancing because that's quite yourself. That's so anyway, I suppose for now that'll be it. I can't wait for it though. I'm sorry, too long, it's already a very long stream. Okay. That'll be it for now. Tifta, if you're watching the replay of the stream, I'm sorry I didn't wait for you. I wanted, but I'm not entertaining. I'm sorry. Alright, that'll be it. For now, thank you everyone so much for watching, and have a great day. Bye.